Good evening, Professor. I'm recording this during the break. Well, it's about to be the break. It's Sunday, but tomorrow will be spring break. I hope that you'll have a good break as well. And I wish you luck on grading the rest of these labs. But for now, I'll talk about mines. And this is Lab 5. So before I continue, I would just like to state that the video that showcases my um, my hardware part for this lab is in a separate video, and it's gonna be provided in the document and the readme file. So if you want to see the video for the hardware, it's going to be there. Now on to the 3 code that I'm showcasing, which is Heart Analysis, Siddhartha, and Red Alert. So before I went ahead with the Heart Analysis, I first used this wave to CSV file to convert the wave file I had into a CSV file. And using that CSV file, I imported that into this code, which calculated a bunch of time domain parameters to analyze the heart rate of a person on top of the time domain, which is calculated here. I also calculated for the frequency portion of the heart rate analysis here. This is where I plotted the heart rate signal in the FFT, and this is where I printed out the results for all of them. And if I were to run this code, it would show around here. This is the heart rate signal. This is the FFT, and these are the printed heart rate measurements. This is the time domain portion, and this is the frequency domain portion. So here you can see the BPM, the IBI, the SDNN, and all of that. While here in the frequency domain, you can see the magnitude of the low frequency, which is frequencies between 0.05 and 0.15 hertz, and the magnitude in high frequencies is also there, which is between these ranges, 0.15 and 0.5 hertz. And this is the high frequency over low frequency ratio. So there's a lot more high frequency than there are low frequency. Now, for the Siddhartha, over here, I put down the model parameters for the Siddhartha, or I guess in this case it's Siddha, because I only used 4 models, and these are the parameters for various models. I put these on first. I use that document that was provided in the lab. These are the time parameters and the differential equations, or at least setting it up. And this is where I implemented the model that uses the provided equations in the document. This is where I plotted the results, and if I were to run this code, this is what I would get. So this is the susceptible, which makes sense. It's always going to go down because the more people infected, the less people are susceptible. And this is infected, this is the diagnosed, and this is the ailing. And yeah, this is essentially my Siddhartha or Siddha model. As for the Red Alert, what I'm going to show here is the code of what I changed in order to speed up the animation of the stars. I simply reduced the duration by half, so it's twice as fast going down as well as going up here. I also changed the direction here. So to change this to change the direction the stars move, I created two animations. This one makes the star go from center to bottom, which is down, and this one makes the star go from center to top, so it goes up. As for how I manipulated my program to shuffle and, well, make the stars go up or down, I simply triggered these functions depending on which star you click. So red star, if you click red star, it's normal function. If you click blue star, it triggers this animate stars too. Essentially, it will make the blue star move up, and if you trigger green, it will shuffle the stars so they will move left and right. And if I run this code, so red, I clicked red. If I click blue though, you can see the blue go up. If I click like red again, I click blue, it goes up. But if I click green, all the stars move left and right. And as you can see, it's also faster. The stars move faster, and as you can see, that's how I shuffled and sped up the stars while also providing two directions, one going up, one going down. And that is all my 3 programs for Lab 5. Thank you for watching. I wish you a good break, Professor.